everybody. The next class is going to kick out all of you. Okay. Oh, I want to go home. All right. Question 4, part A. Question 4, you're doing a survey. Who's going to win? Is it X or is it Y?
X.
Let's say it's X. 1, Y 0. The probability, let's call this the probability is P. Okay? So here is probability 1 minus P. Okay? So you ask you surveyed 100 people, and 58%, 58 people out of 100 says yes for X, or 1 for X. Okay? So your sample average is 58. You have 58, 1, 42, 0 out of 100. The sample average is 0.48. 0.58. This is your estimate. This is your estimate for P. Okay, the sample estimate for P. For the probability value. Okay? So that's A. Correct. That's A. Yeah, that's the point. Your point estimate for P is 0.58. Okay?
So we'd have to write it that way, not 58%, 0.58.
Yeah, so and then we know last time we derived this 0.58 has an error, has a potential error band. Okay? Remember we simulated something like this over a 100 different random number generations. Okay? So they have pretty big error. Okay? Even if the true probability is 0.58, if you just ask 100 people, you can get 0.56, 0.62 easily. Okay? So what is the standard deviation for this number?
1 minus B.
The standard deviation for this estimate, remember, it's just a standard deviation over one case divided by the square root of n. The standard deviation for one case is what? It's P times 1 minus P for the variance. Okay? This is standard deviation, and this is standard deviation. P times 1 minus P is the standard deviation for one individual, for one observation. Okay? This is the standard deviation for this mean estimate. Okay? So P times 1 minus P So the numerator here, remember, is the standard deviation for just one individual. You ask one person, yes or no? Yes. Okay? That's 1, no, and 0. Oh, that has standard deviation of P times 1 minus P take the square root. Okay? So how big is the standard deviation for the mean estimate?
Yeah.
0.5. 0.05.
Okay? Because you have 100 people you survey, the standard deviation now is 10 times smaller. As you can see, I think last time in class we did the example where P is 50%. Okay, so the P is 50%, this is 0.5. So which is to say, when the two parties are really close, the standard deviation is actually bigger. It's very hard to pin it down. When one person has 99% edge, it's very easy to observe the standard deviation gets smaller very quickly. Right? If you look at this number, P times 1 minus P is a quadratic function. It takes the maximum, and P is half. Okay? P is half. It's very hard to learn about true P. Well, when P is deviates from half, the standard deviation actually gets smaller and smaller. Okay?
How do you get to 0.49 numerator?
Plug in a P of 0.485 the point estimate. Okay, so the standard deviation, current standard deviation, was a 2 standard deviation error bands. Okay, 2 standard deviation error bands. That's the polling results. Okay, so 2 standard deviation error bands. We have 58% for Mr. X plus minus 2 standard deviation, 2 times standard deviation of 0.4.9. Okay, that is an interval of 48.2 to 57.8. Is that right?
67.
67. That's what I said before. 56.8. Alright? This is 58%. 50%, 58%, if that's true, in politics, it's an overwhelming support. Okay? But that's like a dominating, very, very dominating position. But if that number is only derived with 100 observations, if you put a 2 standard deviation error band, which covers, about 95% probability, then you see the lower bound is 48.2. If the true support is 48.2, you don't win. You only win when you have 50%, right? So you still can't be 95% sure you're going to win the race if the sample size is big, okay? So I think question part C asks you, what's the chance that although you get 58% in the survey, in the actual race, you actually lost the race? What's the chance of that happening?
The lower one? 48.
50%? Below 50?
Like 42% based on
50.
48%.
The 58% you derive is not 58% of winning or losing. If you ask one person, what's the chance he will vote for you? That's 58% chance he will vote for you. Okay? If 58% is true percentage of people who vote for you, the chance of winning the race is 100%. Right?
So it's 50.
If I ask everybody who will vote for me here, and 58% of you said you're going to vote for me and actually voted for me,
No.
and I'm going to win the race 100% chance. Okay? So that's not 58%, it's not 58% of winning, 48% losing. Okay? It's 58%
Of the people,
There are 100.
of the
voting
votes.
for you for each person. But you have, you pull all these people together. So here, it's really asking this. You survey 58% from me. The survey has 4.9% probability and 4.9% standard deviation. So if survey gives you 58 mean, 4.9 standard deviation, what's the chance the true number is below 50? Okay, think like this. If the true number is actually 50 or lower, there's still a chance you ask 100 people, it turns out 58 out of this particular 100 people support you, right? Just by random chance. This question is asking you, hey, what's the chance, the true number is actually up here, but you ask me the mean of 58, standard deviation 4.9. So it's really just finding out the size of this tail. Okay? As always, get a z-score, and then look at the table. What's the z-score for 50%? Don't think. Just plug in the formula, okay? Z-score is measuring how many standard deviation away from the mean. You're 8% from the mean, standard deviation is 4.9. Just plug it in. 50 minus 58 divided by 4.9. This is 8 divided by 5, 1.6. A little more, 1.61.
Negative 1.63.
Why give it 4.9?
Okay? So the chance that the true number is 50% or less, Z-score minus 1.63, look at the table, okay? So what's the probability of Z-score minus 1.63? Right, 5.16, 5.2, about 5%, okay? So even with 58% support rate, you can still lose the race with about 5% probability, okay? Because this 58%, maybe you just got lucky for this survey. And then last one, all their change.